All right, so now let us go through question number 6 then. We saw how the basics work, right? So 6.1, it reads as follows. We are given basically from the information, we are not given the sketch, rather we are given the equations. We have the hyperbolic function and we have the exponential function, right? So 6.1, they say to us, write down the equations of asymptotes of f. So to answer question number 6.1, we're going to say the equations of asymptotes of f. I said to you it's P and Q. And then P, by the way, it corresponds with the value of x. Ne? So the equation of our asymptote in this case for x is going to be -2. Sorry, +2. When it's negative like that, okay, maybe I didn't emphasize on this one. X minus P, actually it's minus P there. Ne? So we're going to say x minus P is equals to what? Oh, when it's like this, ne? I want to do it like this. This is what you need to know. X is equals to -P, ne? Here we have -P over there. So when you want to determine the equation of asymptote, you're going to say x is equals to -P. Ne? So in this case, we have x is equals to we have negative there, and then we're gonna multiply that by, we have -2. We take out -2 outside inside of the bracket, and then our x will be equals to 2. So basically, when it's already, you can just say when here my value of asymptote is negative, when I take it out of the equation, it will give me +2. You can just do it like that in simple way. Ne? So that's the first equation of asymptote. And the second equation of the asymptote, it's going to be y, right? Which correspond with the value of q. You don't need to write this. I'm just writing it for the sake of clarity. So even q, you don't have to write it. You can just say y is equals to q. In this case, is equals to how much you take it as it is equals to +1. We can see it there, right there on the graph. We have +1. So these are the equations of asymptotes. Then we move to 6.2. 6.2, it says to us, write down the equation of asymptote of G. So now we jump to the equation of G, which is most definitely this equation over here. They want us to write the asymptote. Remember, for G, it's Q, right? Remember, we have something like this. If you still do, remember AB to the power of x plus P. Remember Q, it is our asymptote. In this case, our Q will be -1. So at this point in time, it also corresponds with the value of y. Then it is the horizontal asymptote. So we can say y right there is equals to -1. That will be the equation of asymptote for G. Now, 6.3 want us to draw. 6.3, it says to us, we jump to 6.3. 6.3, it says to us, on the same set of axes, sketch the graphs of f and g, indicate clearly all intercepts with the axis as well as the asymptotes for only 4 marks. You see those basics, né? Those basics should be able to help you to draw the graph, the ones that I started with. Because you don't need, you see it's 4 marks. This thing at grade 9, where you draw a table, X, we don't do that anymore. This thing that you draw a table, it's X values, it's, we don't do that anymore. Ne? That's in grade 9 or 8, somewhere there. So now, here we draw our Cartesian plane, right? Start with our Cartesian plane. Here's our Cartesian plane. We're going to rely on the basics to draw these graphs. Ne? We're going to rely on the basics to draw these graphs. Let me see what's happening first. Some of this -1 there. Yeah, okay. Just want to see how am I going to draw my Cartesian plane. Should take it more down or up. It's fine. will maneuver. So this is the y-axis, and this will be the x-axis, and therefore this will be the origin. This is you in exam, right? You want to draw three graphs. Firstly, you're gonna start. That's why 6.1, 6.2. You're gonna start before you go anywhere. You're gonna start by filling your asymptote first on the Cartesian plane. Ne? So what we're gonna do is we can see that so far we have this asymptote, we have this asymptote, but these asymptotes, they are for which graph? They are for graph of f, if you still do remember. So our x is positive 2, so I would assume there is 1, right? I would assume there it's 1. I go, what's happening now? I would assume, man. You can even take your ruler if you're neat. I used to use my ruler, me, because I was neat. You can even take your ruler, ne? Say 1 centimeter, it's 1, and then 2 centimeter, maybe there it's 2, right? Um, let's see, yeah, that's the maximum. And therefore here, obviously you will have your -1, there you will have your -2. Even here, maybe there you will have your -1, here you will have your -2, even there you'll have your +1, there you have a +2. I will do my Cartesian plane like this, right? Just to be neat, using your ruler, that's it. And therefore from there, let's draw the graph of f then. Oh, let's start with the asymptotes first. The the vertical asymptote for f, it's 2, right? You go to 2, where's your value of x? And then you draw your your vertical line. This is the first asymptote, right? This is your first asymptote. You even indicate that your x here, it is actually equals to 2. This is the y-axis, but the x is equals to 0, 1, 2, but it's y-axis, but yeah. So you indicate there that your value of x, your asymptote there, use your broken lines, right? Or your dotted lines to show that this is your asymptote, right? Right. And therefore another asymptote here, it is this one, y is equals to 1. You go where y is your 1, there is your y there, and then you draw your horizontal asymptote when you get there. You draw your horizontal asymptote when you get there. And then that's it. You see, it's like you made a new Cartesian plane. Look at the original Cartesian plane, xy, and then look, it is shifted there. You get it? Here's the thing, ne? I'm going to tell you something that's very important. Let's reread this question. Let's read again this question. On the same set of x's, sketch the graph of f in your graph. In your bookshop, indicate clearly all intercepts. That's what they need for you to get the marks. With the x's, right? As well as the asymptotes. We need the asymptotes. We need the x-intercepts with the x's. You get your marks from there. Ne? Okay. What we're gonna do before we draw the graph, quickly, you don't have to write it on the book. You can write it somewhere on your script, on your question paper. I don't know where you can, even on your book, but with a smaller nyana, fast. So you're gonna determine the intercepts. Ne? We're gonna determine the x and the y intercepts because we need them. You understand? Oh, by the way, before we can even determine, you see this new Cartesian plane that is made by the asymptotes. Look at the value of a. Is it positive or negative? It's positive. So where are we going to draw our Cartesian plane? So, I mean, not the Cartesian plane. Where are we going to draw our function? Where are we going to draw our graph? We're going to draw our graph in the first quadrant and the third quadrant because the value of a, I told you, it is greater than 0, it's positive. So here, we can just draw a curve like this. We are fine because we don't have the intercept. There is no way this graph will touch x or y intercept. So we don't, for that curve, for this curve right there, it's fine. We can just, let me use the yellow one. We can just draw it like so, ne? This side. So that means we need to utilize this quadrant again. But when we have y-axis and x-axis, so we need to determine whether it's going to be here and there so that we can join those points or where. So that's why we need to determine the intercept. So quick, let us determine the intercept of this graph of f. So how are we going to do that? Let's see. You can just do it now by calculations. Y-intercept, you let x-intercept, you let y to be 0. We have 2 over x minus. This is you in exam. I'm giving you. And then you transpose -1, it becomes -1. You are being fast, right? It's algebraic math. You cross multiply there. There you have negative. You don't need this negative. You can just say x minus 2. Rather, you will change this 2 to be -2 then. And therefore, your x will be equals to, it's going to be +2. You're going to get 0. So we see that when y is equals to 0, x will also be equals to 0. I'm lying. I did my maths wrong here. Did I? Yeah, I did my maths wrong. I see now. Yeah. Oh, no, it was correct. I'm being fast, like this and that is x minus 2 and then -2. Yeah. X is equals to 0. Hopefully you agree with me. So we have 0 is to 0 so far. Even if we want to determine the y-intercept, we're still gonna get that. Y-intercept, we let x to be 0, right? It's gonna be 0 minus 2 plus 1. It's gonna have 2 -2 plus 1. We're gonna have -1 plus 1, and we're still gonna get 0. So it means it's gonna be here at the origin, whereby the coordinate is gonna be 0 is to 0. We get it? And therefore, we are happy. We just determine the x-intercepts and the y-intercept aside so that we can draw the remaining curve of our hyperbolic function, right? So how are we going to draw that? We're just going to say this graph will now move like this. Oh, make sure that you approach your asymptote. Even this side, make sure that you approach your asymptote, and then voila, then this will be our hyperbolic function. We are done with hyperbolic function. Now we move to another function. Let me change the color. Let me use this one. Now we move to another function, right? Which function? The exponential function. Look at the exponential function, g of x. Is by looking at the graph, by looking at the equation of g, what is the value of b? It is 1 over 2. That is the value of b, right? And then, again, I forgot to indicate this, that y here is equals to +1. Okay, let's firstly start with the asymptote, then this side. So the asymptote for the graph is going to be this one. For now, we are drawing exponential on the same set of axes. Now, look at this graph. Look at this graph. What's happening? Look at this graph. The asymptote is -1. Y is equals to -1, right? The asymptote is -1. And again, look at the value of b. The value of b, it is between 1 and 0. 1 over 2 is the same as 0.5. So the value of b is between here. It's between 0 and 1. So what type of function do we have? Do we have increasing exponential function or decreasing exponential function? We have a decreasing exponential function. Why do we say decreases? Because the value of b is between 0 and 1. And how is the shape of this graph going to look like? Most definitely it's going to look like this. You see? All right. So far, we know that our graph actually is going to move like this. But then we need to determine the intercepts. Having the graph like this, what is y-intercept and what is x-intercept. If we want to determine the y-intercept, we're going to let x to be 0, right? We're going to let x to be 0 minus 1. And therefore, anything to the power of 0 is going to be 1 minus 1. 1 minus 1 will give us 0. So that means, again, here, our x-intercept and y-intercept is going to be 0 is to 0, meaning our intercept is going to be here. Remember, this is the asymptote. Do not forget. Okay, let me do it with green color. This is the asymptote. So it's like our Cartesian plane is here. It's here. And therefore, let's draw the graph. And make sure that you approach your asymptote. Don't touch it or don't cut it. And then our exponential graph will most definitely move like so. Therefore, this will be our exponential function. And then we are done. That's it. Okay? So that's how we go about for these questions. All right. Do we have questions or we understand from 6.1 to 6.3?
We understand.
Okay. Tando?
Yeah, I understand.
Okay. So now let's move to 6.4 then. Now 6.4, 6.4, it says to us, write down the domain of F. 6.5, write down the range of G. And 6.6, determine the equation of H, the axis of symmetry of F, which has the negative gradient. You see, well, guys, let me be honest with you. You see this question, determine the equation of H, which is called the axis of symmetry of F, which has a negative gradient. Hey, I'm just quiet. Okay, let me go back. I think, yeah, I'll be able to squeeze 6.4 and 5 here. Yeah, no, it's fine. I'll be able to squeeze them here. So let's see. So now, 6.3, 6 point what? 6.4. They want us to write down the domain. What is domain? Domain refers to the values of x. Range refers to the values of y. Ne? It's the same thing, just that domain is the values of x, range is the value of y. So we want the domain of f. Let me do this. This graph over here. Oh, this one is graph of G. This graph over here, it is the graph of f. So if you draw your graph correctly, you're going to easily answer 6.4. Ne? So because I analyzed the domain from the graph schema. So 6.4, we want the domain of f. Where is the graph of f? The yellow one, right? The yellow graph, the yellow one. How are we going to determine the domain? We're going to look at the values of x. We're going to say the domain of f, x is the element of all real numbers. But there is an exception. Then what is that exception? It is that x may never be equals to the asymptote, in this case, which is 2. You get the yellow graph. Any value of x, it qualifies to be the value of x for that graph, except the asymptote, because our graph doesn't pass through asymptote. Our graph doesn't touch us. So here, when it gets here, our graph, when it gets here, in terms of x values, it doesn't touch. So 2, it is not the element of this domain, of the domain of x, of f. So that's how we write the domain of f. And then 6.5 says, or if you don't want to write this, if you don't want to use this notation, I don't know, maybe you can use a set builder notation, which is how is that one goes? Okay, you can say X is the element of this set. You use a set, ne? Then I say X is the element of you use your what? Konje, we don't include the domain. We don't include the true, ne? You can say X is the element of, you start from here, from negative infinity to positive 2, and then you write the round bracket. You don't write the round bracket, ne? You can do it like this, and therefore, or do not use and do not use the union, and therefore, or starting from 2 to positive infinity. It's either you use this notation or you use this notation. It does not matter. So why am I saying you use your round bracket over here? Because we are not including it. Remember, I told you that if you have a square bracket and then you have these inequality signs and then you have the shaded dot, we are talking about where you excluding the values. But if you have your round bracket and you have these inequality signs and then you have the circle that is not shaded, we are excluding the values. For an example, X is greater than 4. X, it is excluded. I mean, 4, it is excluded. But when you say X is greater or equals to 4, we are including, because we say it is greater and equals to at the same time. So we are including the value of X. So when you have 4 and you write the square bracket, that means you are including 4. When you have 4 and you write the round bracket, that means you are not including 4. When you have 4 here and then you do the circles, you do unshaded circle, that means you're not including 4. But when you have 4 here and you are shading your circle, meaning you are including 4. Okay. So yeah, that's maths has a lot of basics. So that's just how it goes. That's why we write the square brackets here, not the round brackets. So you can use this notation, but I know you would prefer this one. This one is much more simpler. So here you will even do your mistakes. So stick on this one, the first one that we started with. It's optional. It's optional. And then 6.5, they want us to write down the range of G. G is the green graph. And then what is the range? Range, we are referring to the Y values. Now look at the graph of G. Ne? The graph of G is exponential. And it has an asymptote where it stops, where it never, like where it ends. So to write the domain here, to write the range here, it's very simple. Ne? It's very, 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 very simple. You can use it, however, the simplest one, you can say Y is supposed to be above the asymptote. Our asymptote is -1. Y is greater than -1. Do not include -1 because we don't include, it's as our graph doesn't even touch -1. So we don't include it, we exclude it. That's why we use this inequality sign. So I'm sorry about that. So we're gonna say Y, it is greater than -1, and this will be the domain. I mean, this will be the range of graph of G. Or if you don't want to use this notation once more again, you can use that self-builder notation. You can say Y is the element of, you start from -1, but you use your round bracket because you are not including -1. To positive infinity, it goes to up to positive, from -1 up to positive infinity. And then again, for infinity, we always use the round bracket because infinity is a number that we do not know, so we can't include it. It's just a long number that we do not know. We understand? So that's just how you can write the domain and the range of these functions. So before I jump to 6.6, do we understand how to determine the domain and the range?
Yes.
Yes.
Yeah, I'm trying to be slow and elaborative and informative as much as I can, okay? Because I don't know, and we still have time, man. You're not writing as yet. It's not like you're writing tomorrow. So yeah. And therefore, let's jump to 6.5. Now, 6.5, 6.6. 6.6, it says to us, determine the equation of H which is the axis of symmetry of F. F is the yellow color. Axis of symmetry of F, which has a negative gradient. Aha! Yeah, here comes my people. You see the basic that I taught you? It's gonna apply now. It's gonna apply now, the basic that I taught you. So they said it's supposed to have a negative gradient. What? The axis of symmetry. So what is the name of the equation? It is called h of x is equals to mx plus c. Why am I writing that? Because axis of symmetry is a linear function. So they want us to determine that equation of h of x. So how are you going to determine that equation? Now, I said to you, axis of symmetry will always pass through the origin. But which origin? This origin of your asymptotes. Always know that, ne? Maybe I should have specified again. Through the origin of the asymptotes. This is where asymptotes intersect. So it's either our axis of symmetry moves like this, right? Or it moves like this. But we were told that we need the one that has a negative gradient. The one that has a negative gradient, that means it's gonna move like that. You get it? So this is the graph of h of x. They want us to determine the equation of this graph. So what is the gradient of axis of symmetry? Will always be 1. But in this case, our axis of symmetry is going to be -1. The gradient is going to be -1. So far, our equation will most definitely look like this. Y is equals to m is -1 multiplied by x plus c. So far, this is how. So the equation 8 is not complete. Why? Because we need the value of c. As long as we get the value of c, we substitute it back, and then our equation, it is now complete. You understand? So the question is, how are we going to get the value of c? So now we need 2 points of which this graph passed through them. So we can see that this graph of h, it passes through this point of intersection here. So what are the coordinates of this point? Remember, the x there, it's 2. The y there, it's what? It's +1. The 1 there is +1. So it passes through 2:1. Which equation? The axis of symmetry. It passes through that origin of the asymptotes where it is 2:1. So we substitute our our y here, which is 1. We substitute our x there, which is 2 plus c. Let's solve for c then. So it's going to be -2. When it comes to this side, it's going to be +2. Therefore, our c will most definitely be equals to 3. Therefore, the equation of axis of symmetry y is equals to -x, and then our c now, it is +3. Therefore, that's why it passes there. Remember, c, it is the y asymptote. That's why maybe somewhere over there is going to be +3. It makes sense. So about even how we draw it, it kind of makes sense to us. And therefore, but by the way, this is how the equation will actually look like. Are we happy? Are we happy, guys?
Yes.
Able.
Okay. So that will be 6.6. Not like saying, yo, I understand, guys. It's schoolwork. Schoolwork is a lot, right? So now 6.7. Let me try to be quick on this one. Even if I become quick, guys, you won't get me. That's what I'm saying. We can do one question for the rest of the year. Everything will be fine. As long as you understand everything that I said, you will be able to answer every question. So now, 6.3, it says, describe how the graph of P of x, which is given to be 2/x, was transformed to obtain f. This is a very interesting question. And it's nice because it's not even you thinking out of the box, it's you being able to know how to analyze this. They said, initially we had a graph of f, if you still do remember, before we can answer 6.7, the graph of f, it was given to be what? It was given to be 2/x minus 2 plus 1. 2/x plus 2 minus 1, right? This is the graph of f. So 6.7, it says describe how the graph of P, apparently we have a new graph, and this new graph, it is 2 over x. So we want to describe how does the graph of P of x was transformed to obtain f. So meaning what are we going to do to this graph so that we can get this graph that looks like this? You can see, man, this graph is very, very simple. You have 2 over x, So to get the graph, to transform this graph to there, what are you going to do? Guys, you can even look at it. You're just gonna add 2 there. You're just gonna add -1 there. It will take you back there. If you take, so, but the question is mathematical. How are we going to put it down? What are we going to say to answer that question? To describe this, we're gonna say, to describe this, we're gonna say, look, remember I said to you, or I never spoke about it, but this is where I want to talk about it here. So P, it affects the x values, meaning P affects, it shifts the asymptote along the x-axis. It's a horizontal, it's more like a horizontal shift, né? And then Q, which is this value over here, Q, it's the horizontal, it's the vertical shift. It shifts the asymptote along y-axis, which is like horizontal shift. You understand? So meaning in this case, how are we going to answer this? Remember, this is the horizontal part, and this is the vertical. This is the vertical part, right? Or you can say it's left to right. And then for this part here, which is this part, it's up or down, up or down. This part, it moves up or it moves down. This part, it moves to the right, or it moves to the left, which is +2 there it's -1. So we want to know, what did we do to this graph to get there? What did we do? You're gonna say you added 2. You're not gonna put it like that. You're gonna say you shifted, we want the transformation, right? We are describing mathematical. You're gonna say shift the graph, shift the function, or you can say shift the graph 2 units to the right. Why am I saying I shifted this function 2 units to the right? Okay. We want to go back here, from here to here. Or how did we describe how the graph of P of x was transformed? Yeah, to obtain f, right? Not this to this. It's not like f to p. It is from p to f, because describe how the graph of p was transformed. Yeah, okay. So now look, here we have 2, we have +2, right? Remember this +2, when it gets outside of this, oh, I see what I did. I confused myself by writing it this side, but it's not necessary. I just wanted to show you. Yeah, I was supposed to write maybe this side so that it makes sense better. So I left or right this side, here we have -2. So remember, this thing is +2, but when it comes outside, it becomes -2. So our graph initially was here, this graph. The asymptote of this graph, the asymptote was here. So we shifted it 2 units. Eh, when it's positive here, let me do this. I'm confused, David. Oh, yeah. Remember, this graph was here. Okay? We have +2 over there, right? Oh, guys, why did you tell me, or I made a mistake here? Yeah, it's not a +2 here. It's -2 there. It's -2 here. Yeah, I'm like, what's happening? I'm confused now. It's -2 here. I guess we took it from here, from this graph. Don't forget. I don't know why did I write positive then. That was just a silly mistake. Hey, I'm confused now. I'm like, hey, what's happening? Right. So from here to here, we shift 2 units to the right, right? So that means it was 0, but now it became positive 2. So yeah, it was still fine. It was this side. So we moved 2 units to the right. Our asymptote was here at the origin. So we shifted it 2 units to the right. So that's why we shift the graph 2 units to the right. And therefore, look at this one. There it's 0. We have 2. Again, here we had 0, so we just inserted -1 over there. And 1 unit upwards. So that's how we transformed the graph of P to obtain F. 2 marks. And then we move to 6.8. 6.8 says to us, calculate the distance between the intersection of F with G and the intersection of asymptote of F. So we want the distance between the intersection of F and G. This is the intersection of F and G, right? Right? You see it, the origin. And therefore, which distance again? But from where to where? At the intersection of F and asymptote of intersection of the asymptote of F. Intersection of the asymptote of F. These are the asymptotes of F, remember? This part, this thing over here. So we want this distance from there to there. So we're going to use the distance formula because we know the coordinates over there. Here it's going to be 0 is to 0, and then there's going to be 2 is to 1. We use a distance formula to determine that distance. Simple as that. Okay? So that's how we're going to answer 6.8.